Deoxyribonucleic acid, or DNA, is the foundation for all life on Earth. It's a remarkable molecule acting as a blueprint for building and maintaining living organisms. But have you ever wondered if DNA is the only possible basis for life? Could entirely different biochemistries exist somewhere else in the universe? DNA has 4 building blocks: adenine, thymine, cytosine, and guanine, which are arranged in various sequences to encode all genetic information. And these are molecules that have carbon as their backbone. DNA is incredibly efficient and stable, which is why it works so well for life as we know it. But in the vastness of the universe, researchers believe there may be other chemical systems that can support life in entirely different ways. Take, for example, silicon. Silicon is chemically similar to carbon, given that they both belong to the same group on the periodic table and therefore have similar bonding behavior. From what we know here on Earth, carbon's ability to form long molecules is the primary reason why life is as complex and diverse as it is. And since silicon has this property too, researchers think it might be able to create the complex molecules needed for life. Just as our cell walls are made of carbon-based lipid chains, life elsewhere might rely on silicon chains for this purpose. Astrobiologists believe that silicon-based life could exist on hot, rocky exoplanets or moons with high pressures, places we know to be too extreme for carbon-based life. But what about water? From what we know, water plays an important role in both building and sustaining life. What happens in environments where water cannot exist, like on hot exoplanets or icy moons such as Europa? Could water be swapped out for a different solvent? Water is essential for life on Earth because it allows the chemical reactions of life to happen. But in cold environments where it cannot exist in its liquid form, scientists believe chemicals like ammonia might be a good substitute for water. Ammonia stays liquid at much lower temperatures and is also polar just like water, so it might be able to play the role of a solvent on worlds much cooler than Earth. But all of this is speculation since we haven't visited any exoplanets or moons yet. Is there any concrete evidence for the existence of alternate biochemistries? Well, researchers are exploring molecules called xenonucleic acids, or XNA. These synthetic molecules work like DNA, but they have entirely different chemical backbones. Experiments have even shown that XNA can replicate and store genetic information just like DNA, and is also resistant to natural enzymes that could break down DNA and RNA. This means life could encode its genetic information in molecules other than DNA or RNA, and could withstand environments which we might find harsh to live in. Given how vast the universe is, there could be many different ways in which life could arise, and many different molecules that could form the backbone for life elsewhere. But by broadening our horizons beyond DNA, we are not just expanding our understanding of life, but also broadening the way we search for it in the universe.